Hello, and welcome to another stream. Today is going to be a really exciting stream. We're going to finally get to training our real reinforcement-esque learning Pokemon battling AI. Theo is here as well. He's very excited. Say hello. And so today's going to be a busy day, but we've got everything that we need already prepared for us. The data's ready. So there's nothing standing in our way. It'll just be training it. No promises about how good it's going to be by the end of just a couple of hours of training. But either way, we'll get something by the end of the couple hours. And the last bit of stream today will be using that model, as bad as it may be, to play some real games on Pokemon Showdown. We'll probably try playing myself, just on Pokemon Showdown. Viewers from chat will try playing Pokemon Showdown if you're interested. And lastly, we'll try just playing some random opponents and see how it goes. So without further ado, I'm going to set down Theo, and we're going to get started. See you later, Theo. Okay, so let's get started. What we need to do is we need to read in the data that has been prepared for us previously and use that to train our model. So what we're going to do, last time we were creating 1 million battles of simulation data, just random players fighting in different ways. What we're going to do now is use the results of those simulations to train a model. So unfortunately, our 1 million battles didn't finish quite in time for this stream, so we'll just be using what we do have. Right now, instead of 1 million battles, we're at like 930,000 or something. This is because I had to stop it and restart it yesterday because of a slight issue. We weren't tracking the turn number, which for future things we probably will want the turn number. We're not actually using the turn number for anything right now, but it was worth it to still stop it. So we've stopped it. And for training today, to keep it relatively quick, we'll probably train on a smaller amount of turn data. I say smaller because it's still going to be a decent amount of data that we're training on. It's just going to be a little bit more specific in scope. So we're just going to train it on a smaller, more relevant set of data that's about like 15 million turns of data. So this will still be a large amount. Don't get me wrong. We'll still be able to get a lot of information from this. But it will not be the full picture. The full picture we'll probably just leave on over the full weekend. And by the time I come back to stream next Tuesday, we should have something more to show. So let's start by actually training a model and loading the data and what we have to do for that. So I have a lot of extra windows open. Let me close some of the windows that I don't need anymore. Okay, so with a new window, I'm going to go to our Jupyter Notebook, into Notebooks, and I'm going to create a brand new notebook. I'm going to go ahead and shut down the old one so that we have all of our resources dedicated to just this project. It's pretty important because this is going to be very resource intensive. Okay, and then I'm going to get started. So the way that our data is, let me pull up a folder so you can see what the data looks like. Zooming in. Okay. Basically, I have processed the log that we originally created, which had a whole lot of just battle turn information. Last time we were writing a script, which I'm going to go ahead and rename something helpful, which is MBS log parser, which is million battle simulation log parser. This one is going to be, I'm just going to go ahead and shut it down and so we can rename it. This is going to be our simulation model trainer. This is because our approach to doing the AI in this case will be broken into 2 steps for the battling. We will first pre-train a model on some simulations and then train it in a reinforcement learning style, which is much slower but has the potential to create a much better model. But first, of course, we need to train an initial model that can be good enough. So let's import some basic libraries. Oh, and zoom in. There we go. Import pandas as PD. Import numpy as np. Import tensorflow as tf. And I think that's about it that we need. Except tfio will probably need we will need tfio. We might not have tfio installed, so we might have to install it, but I think it'll probably be okay. Yep, we don't have tfio installed, so we need to just install that. Is there any sort of special way to install it, or can we just go ahead and directly pip install? Yep, we can just directly pip install. So that's great. No issues there. Let's try importing everything again. Okay, everything is imported. So now we're good. What these files are called feather files. It's basically a more efficient way of storing data that you would typically store in like a CSV if you were doing things with pandas. So it's not a very user-friendly format unless you're doing things in pandas, in which case it's very fast, much more file efficient or file size efficient, and just all around a better thing to use for pandas. No inconveniences if you're already using pandas. So what we'll do is all of the results from our MBS log parser, which we wrote last time, they get stored into individual feather files. Each one has 100,000 turns of data. But we can't just load everything into memory because if you'll notice, we've got 154 files here, and the memory size grows pretty fast. Each one of these is 60 meg. And this is just for what has run so far. This does not represent the whole 900,000 battles. This represents probably a very small fraction of that. I don't actually even know how many battles this represents. Our million battle simulator is still running. And it'll finish while we're streaming. So we could also run this batch creator in the background too. So we just get more and more data. But I think 150 odd batches, which represents 15 million turns of data, will be fine for what we're doing right now. So what we're going to do is we're going to need to create a TensorFlow dataset. And the way that we do that is by using this TFIO library that we just imported. They have a function that allows us to pull exactly the information that we need. So let's go ahead and do that. So how we do that is we just say something like I just had to check. We first need to get the spec of a feather file, so it's not as easy as it could be. What we can do, actually, let's just show what this data looks like in pandas. Rather than doing TensorFlow first, let's say pd.read feather, and we're going to read batch data slash batch 153. That's the last file that we have, .feather. And it takes a couple of seconds, but we just loaded 100,000 rows with 11,272 columns of data. And this is what the data that we created last time looked like. It's got lots and lots and lots of columns based off of what you have chosen to do, what the weather is, what Pokemon you know of, what Pokemon are in which slot, what abilities do you know that Pokemon have, etc. So this is a huge amount of data, 11,272 columns. So we need to get some information about this data. So there is a function with TFIO that we can very easily use, which is this list feather columns function. So feather columns is going to be tfio.arrow.listFeatherColumns, and we're going to give it the same file, just because TFIO claims that it needs this information. If we see what it looks like, it says TFIO has no attribute arrow. Is this an old version or something? Let's verify that this stuff works, because it says that TFIO has no attribute arrow. And that would kind of spoil some of our ease of use if that's the case. Let's just look it up. Already hit a snag 10 minutes into it. Let's check our TFIO version. 0.24. Okay. Let's restart and run. Let's just restart the kernel, because it could just be a simple import issue. Sometimes that happens when you fresh install a library. Module TensorFlow IO has no attribute. Let's check out TensorFlow or TFIO. It's got experimental, but it doesn't have arrow. Awesome. We can go to the GitHub page for TensorFlow IO and see what's going on. Yeah, they still show tfio.arrow though. Let's look it up on their GitHub page. Here, let me move this page over so I can show what's happening on GitHub. So we can see what's going on. Let's see if they like removed arrow or something from a recent version. Yeah, added batch string support for Apache Arrow. And then they haven't specified anything about removing stuff. So they've got audio, big table, experimental. They don't have BigQuery. What's in Python? Maybe they restructured things. API experimental ops. That doesn't show up here at all. Tensorflow docs. Why? API has, again, no arrow. We could install an older version and see if that's what it is. Because maybe they removed it or something? Did they move it into experimental? Maybe there's like a special way you have to install it. Oh, using Apache Arrow. Maybe there's something that is relevant here. No, they just say import tensorflow.io. It could be a special install. We have to install it with a certain package. I'm not sure. This is just configuring Visual Studio Code. I love it whenever we have to just diagnose issues for 20 minutes right at the start of the stream. Let's try doing this to see if maybe it's an incompatibility issue. Because maybe our version of TensorFlow IO is not compatible with our version of TensorFlow, and so then it's removing it. Yeah, here's .arrow.py. And init has, yeah, here it is, arrow.py. What test is it failing? Okay, so I might have just updated my version of TensorFlow, but let's restart and run ourselves and see if it worked. Yeah, module TensorFlow has no attribute arrow. Am I just missing something? Like, am I dumb? As arrow IO. Okay, so you just can't. I guess it was something with the import. It didn't like that I was doing tfio.arrow later. It wanted me to do arrow IO. That's really weird. I don't know why that worked, but the other stuff didn't. Oh well. Does it work now? Nope. Not a feather file. How is this not a feather file? It says .feather. Okay, so let's look back at the API and let's see how to use this. Let's view the source of this on GitHub. So it's failing where it's claiming it's not a feather file. Did I misspell something? No, I didn't misspell anything. All right, well, let's move on and just follow the example or something. I'm gonna close a lot of these other tabs out now that we've at least got it importing. And we can go to overview and go to this tutorial about using Apache Arrow. Okay, so columns just needs to be a list of which columns to use, and output types needs to be what types they are, and then output shapes, we can just have it infer. We don't need it to be specified. So instead of doing this, what we can do is feather columns is just going to be equal to df.columns, but as a list, just in case. So, all right, there's that. And if we see feather columns, this is a list of all of these. I think it might want the indices of the columns and not the actual column names themselves, which means we can actually want something that's like list of range to the length of df.columns. And you can see it's just a list of 0, 1, 2, 3, 4, etc. all the way on to however many there are, which there are a lot. And then we need to do something like feather types, which is going to be the types in TensorFlow of what things they are. I think basically everything's a float, though. Like if I do df.dtypes, everything's a float 32. If I say equals np.float 32, and then all. Oh, they're not. Which one isn't? Because we could probably just convert those and be fine. Ah, some of them are float 64. What about anything other than those two? Because we don't need float 64 either. We don't need to specify. Oh, this should be an int. And something is an int. Okay. So we can just turn everything into an np.float16. So we can just do something like output types. Do we need to specify output types? Yeah, we have to specify output types. So output types is just going to be np.float16. Apparently that's just a more efficient way of storing floats. It just takes up less space. And supposedly TensorFlow will then be able to use like the special tensor cores on an RTX graphics card for training. Don't know if it'll actually make a difference, but since we don't need the precision at all, we can do this, and it'll help memory as well, the speed of training, all of that. So for blank in feather columns, and I'm just gonna cut this and paste it here. And now what we can do is we can set up our data set. So, let's also import glob, because we need glob. From glob, import glob. So our feather files is equal to glob batch data / star.feather. And lastly, our data set is going to be arrow io dot arrow feather data set, and we just feed in these three things: feather files, feather columns, and output types. Let's go ahead and also give it a batch size. I don't know what will be a good batch size, so for now I'm just going to do something like 64. That might be really small. Yeah, we'll do like live testing at the end of this stream. So right now we're just loading the dataset as a Tensorflow dataset, which will let us train the model by streaming the data from files into the model. This is basically replacing just passing in a pandas data frame into the .fit function whenever you're training a model. That instead will pass in this data set and it'll be able to more efficiently train. Also, I am a little bit worried that as soon as we create this data set, my memory is going to get spiked, or my GPU memory is going to get spiked. So I need to copy paste my GPU memory limiting so that no matter what, I am safe. Okay, there we go. And I've limited it right now to 4 gigs of VRAM, but we can definitely step that up. Okay. Load our data, and then this is going to be our data set. Unfortunately, TensorFlow datasets are a little bit muddier than other things. Okay, is subclass arg1 must be a class. What does that even mean? Let's just check here. Maybe this is supposed to be a list. Super.init convert legacy structure is subclass a sparse tensor. This whole TensorFlow IO feather stuff has not been the most supportive of our things that we've been trying to do. Oh, file names wants it to be a TF string. Okay, or Python list. Then what's the issue? Do they have any sort of special installing of this library? Yeah, I think I should do that. If you have any suggestions of who I should rate, I'm completely open to rating people that Twitch chat or YouTube chat recommends, though I don't think there are any YouTube chatters. I think it's just Twitch chat. But yeah, absolutely, I think that is a good idea. Maybe it's an issue of my batch size problem? Nope. Is subclass must be of type class. Let's look this up for TensorFlow IO. What is causing all these problems? When's this article from? 2019. Oh, so much has changed since then now. I don't understand what the issue is. Like, what version of TensorFlow IO are they using? They're using TensorFlow IO 0.8.0. Maybe I should just install a different version of TensorFlow IO. Like, maybe that's the issue. Like, let's try pip install, actually, let's check TF version. What version of TensorFlow do I have? 2.8.0. That's the latest. Let's install TensorFlow IO with TensorFlow equals they had a chart of other versions to use. Let's try let's try like 0.22.0. Maybe installing an older version will be good. Okay, so I'll have to see who would be streaming around the time that I'm finishing up, which is about like midnight JST. Yeah, that's true. I saved these as feather files because it just made the saving so much easier, and I saw that it was one of the supported items, but this release came out 13 days ago and maybe it's broken some stuff. What else could I do? Well, we're installing this version right now. Where all does arrow appear? Okay. Let's try this again. I'm going to restart and run all cells again and see if maybe this time it'll work. Arrow only shows up here, and they just say that they add batched string support for it. The procedure entry point could not be located. Not implemented error. Okay, so I might have messed up this virtual environment. But on the bright side, that's the reason why you use virtual environments. I'm just gonna go ahead and close this virtual environment and start a new one. That way, it's just a clean start. Thanks a lot, TensorFlow. Oh, actually, no. Blender AI / Pokemon. Nuzlocke AI. Python-env. New env. Okay, And now let's do new env / scripts / activate. We're gonna pip install TensorFlow or we'll say TensorFlow IO with TensorFlow version 0.22.0. That should give us the right version of TensorFlow that we want to use, and the right version of TensorFlow IO, or at least an older version. Luckily, TensorFlow is much easier to install than it used to be, so rebuilding the virtual environment isn't actually crazy annoying to do. But it still does take a couple of moments. In the meantime, let's check our progress in running the battles. We're at almost done. It's at like 950,000 battles. Because there's like 550,000 here, and then there's like 400,000 in another one. Okay, now let's here we'll do pip install pandas, PyArrow, Jupyter, SciPy, why not, Plotly, I think that's basically it that we need for this. It's installing all of that. I think maybe what caused some issues is I installed something that was incompatible with this version of TensorFlow, and maybe they haven't got their kind of conflict stuff working in a proper way. I will say some of the other data sets I've used in the past have been much easier than this, so I don't know why this is such a pain. But what we can do after we get this imported is we can kind of show some of the information. So if we take like a model, like this tutorial, for instance, they're creating the model, and then you can just directly fit it on the data set, and any sort of validation, etc. is just handled by the data set that you pass in. So it's very easy. Okay. It finished the install. Let's do python -m Jupyter notebook. Okay, got the Jupyter notebook back, so we've recovered a little bit. Let's hope this works now. Otherwise, we might have to convert the file into something else or try something else. Type error. Okay, so it's a different error this time. Nope, it's the same error. Is subclass arg1 must be a class. But why is it doing that? Flat class is what's getting passed in, but what is flat class? Output types is something. Output types is what's causing the issue. It has to be a tensor D types. Or, well, it says just tensor D types, but the example showed, what did the example show? It showed a tuple. Is that really what's causing the issue? Is this supposed to be a tuple? Oh, wait. No, it's just supposed to be TensorFlow types instead of NumPy types. Maybe that's it? Well, let's change it to a tuple. That's literally what it was. Okay, so it was just that the output types had to be a tuple, and they also needed to be TensorFlow things. Okay, so we've got the data set up, but if we just say dataset, it's gonna be just a bunch of nothings. So what we need to do is do dataset.take1 or something. Let's see. What would be a good thing to do? Maybe something like for record in dataset dot take one print record 0. Maybe that'll work. Oh, internal error. Self.next internal. Expected dtype 19 but got dtype 1. Oh, you know what? Maybe... Well, that doesn't really make sense. Did they convert their data frame to have those types? Doesn't seem like it to me. These are just numbers. Let's follow exactly this step. Print next ds iter. Oh, I called mine dataset. It could be the data type mismatch. I can't just easily convert everything. Let's try doing this. Instead of doing this, let's do df.to feather example feather dot feather. Oh. And then instead of feather files, we're just gonna do this one feather file. And we're gonna say for call in df.columns, df call is equal to df at call dot as type np.float 16. So we're gonna convert everything manually to these float 16s, export it as a feather file, load just that feather file, and see if it gives us the same issue. Maybe? It's taking a long time to run. I don't know which part is taking a long time. I probably should have printed progress on this or something to see if maybe that took a long time, but I doubt it. Is the example feather file written? Let's check that. Example feather was written, no problem. So maybe it's the printing next on ds iter. It's got a lot of columns or something. it really does not want to work. Does it have to do with the output shapes? Yeah, let's just stop it. Let's see maybe where it got stuck. Oh, it got stuck inside of this. Okay, so let's also do output shapes. Is equal to, let's copy this, and instead of doing tf.float16, we're going to do tf.tensorshape. For batch mode, we're going to do I guess we can do batch size. Sure, we'll do batch size here. So output shapes is output shapes, and then we're gonna give it a batch size of, let's say, 64. Or you know what, just 8. Let's see if that takes time, and let's just say print creating dataset. Dataset created. Okay, so the converting stuff is happening here, which takes a little bit, and then it will save it to a file, which also takes like a couple of seconds. CSVs of this much data take minutes, maybe like 10 minutes to store. These take like, you know, maybe 30 seconds or something like that. At most to store. Oh, and I guess I'll also do a TQDM. Oh, need to install TQDM. There we go. And now let's add the TQDM so that it's clear. Print converting types. Print saving to feather. And let's just restart and run all cells. Oh, converting the types to float 16 is taking 4 hours to do. That's crazy. Is there a more efficient way of doing .astype? Oh, that's not what I wanted to do. Hey, welcome back to the stream. We came into this optimistic that it was gonna be very nice and easy, but we've hit like roadblock after roadblock, just causing some minor inconveniences. So hopefully we can figure this out. I think we can figure it out. I was not expecting the converting types of the data to be such a mess. But I guess what we can do is just, instead of converting the types to np.float16, we'll just not convert the types to numpy.float16. Let's see if, you know, float32 or even float64 is faster, or if it's just everything is slow. Okay, everything is slow. The only fast ones were the ones we had already done. If I'd have known that, then I would have just made sure everything was the right type whenever we started. In that case, we'll give up on the future efficiency of the model by doing everything in float16. And instead what we're going to do is... let's see. The RAM usage is fine. It's like 50% RAM usage, less than that. Let's be specific then. So what we're gonna do is we're gonna create a type mapper function that, given a type, so column type, we're gonna say if column type is equal to np.float 32, we're going to return tf.float 32. If column type is equal to numpy.float 64, we're going to return tf.float 64. If column type is equal to np.int 64, we're going to return tf.int 64. Else we're going to raise a runtime error. Unexpected type. Column type. Okay, and now this is going to be type mapper on call type for column type in feather.columns. Oh, for call type in df.dtypes, actually. Okay, we do need to restart and run the cells, just because we were messing around with df. But on the bright side, now we probably... Well, actually, you know what? Let's still leave that saving to feather thing. So that we can test it on just one file. Okay, and that created the data set. Let's see if that fixed our runtime issue that was causing problems earlier. Internal error. Arrow arrays with null values are not currently supported. I thought I had done fill NA with 0. Let's say df equals df.fill NA 0. Let's try that. Because I didn't think there would be NA values. Now we have been sure to fill NA with 0. Memory usage is climbing a little bit, so it's doing something in the background. Last time it failed about now, so if it's not failing, then maybe that's a good thing. Okay, it printed. And so it's a mess of information because TensorFlow datasets are not meant to be people friendly, they're meant to be machine learning friendly. And we can see if we look at this, that basically it's a list of a bunch of smaller tensors that have different values, each of shape 8, because we specified the batch size to be 8, with some sort of NumPy array of values, which basically all of them are going to be zeros for everything, which makes sense. Then what we are looking at is just, it's a list, and it's probably 11,000 elements long. Okay, so our dataset works now on one file. Unfortunately, there are some NAs somewhere, so we might want to fix that on all of our files, but I think for now we're just going to use this one batch, so it's training on 100,000. Once we get it just running all the way through where it starts training, we'll replace this with the full list and figure out what to do about filling NAs. Since this filling NA thing, like loading, filling the NA, takes like... so I just got rid of it, but if we scrolled down long enough, we would have seen things that weren't zeros. It's just that most of the columns will always be 0. Okay, and for now, a batch size of 8 is fine. We'll increase the batch size based off of the memory usage of the GPU. For whatever reason, whenever my computer starts having like a decent amount of memory being used, dragging windows slows everything down by a huge amount. Like maybe if I upgrade my computer to like Windows 11, that's something that's been solved. I have no idea. But like it's very, very slow for me to drag windows around. Okay, so we've got the data set. Now what we can do is actually just create a model already. So if we look at df.columns, oh no, it's sorted alphabetically. I forgot that I ended up sorting everything alphabetically. So df.columns, we need to find out which index it is. So let's do call for call in df.columns. If, I think it's like game score in call or score. Game score. Yep. Okay. So now we just need to know which one that is. So if we say df.columns.find game score. What is it? Python list find first occurrence index. Dot index. Okay, 9713. So that was a mistake. I shouldn't have just sorted everything alphabetically. I should have taken the game score and had that all the way as the last column. But it doesn't really matter too much. But the important thing is that our game score is our like actual index, or it's our actual thing that we're trying to predict. We can replace this with a smarter calculated item. But for now, the game score is a simple basic score of what happened in the game. And with bigger numbers being better. Okay, so we've done that. Now if we wanted to train a model off of it, we need dataset to look like something that has the input and the output. So their dataset looks like lambda L x0 x1 is equal to tf.stack x0 x1 with L. Okay, I understand what this is doing. Basically, we need to stack all of the columns that are in the X input into one vector and all of the ones that are the label into either one, and it needs to be this tuple format. Is there an easier way to do this? Maybe not. I don't know. Because unfortunately it's our inner one. So let's say something like def format as training. And it's going to take in a list of args. Hopefully this is supported for mapping. And what we need to do is we need to get the 9. This is not flexible to input. In my clean function, I need to make sure that the output is always the rightmost one. But oh well, for now I think it's fine. So we're gonna say something like input stack is equal to tf.stack args A for A in args if enumerate args if E is not equal to 9713. Maybe maybe that'll work. Also, this is a function, and I'm gonna expand this window a little bit. Axis equals 1. Output is equal to args 9713. Return input stack output. All right, who knows? Let's run it and see if this works. So then we can say dataset is equal to dataset.map format as training. Yep. We just pass in a function, and that's enough. Let's see. It might fail. This is the first time I've actually used just a flexible list of args. Ooh. What is the error? We scroll down. come back to bite us. It doesn't like that we're stacking things that don't all match each other or something. Okay, let's go to Tensorflow Datasets and see if there's just a convenient function that will do what we want to do. Because maybe there's just a convenient function to extract one column. Structured data maybe. See the guide. TF data. Okay, so what we want to be able to do is we want to be able to just extract one column from the information. So I'm gonna take a quick break real quick and get another drink and come up, but in like 10 minutes I'll be back and we'll solve this issue. Alright, I'm gonna take a quick break and I'll be right back to eat dinner and then I'll solve this issue. Alright, I am back. Just had dinner real quick. Okay, so it's another thing biting us because of typing information. What can we do to try to split this into multiple columns easily? Yeah, so I think some of the general ML tutorials, like right now, if you want to learn about what machine learning is, or even like some specific things of like, you know, how to do image recognition or how to do, you know, reinforcement learning, there's a lot of videos out there and a lot of courses out there about that kind of thing. But I think something that would be interesting to try to tackle would be some of the more kind of nuanced things of like how to manage a project of machine learning, how to go and get help about things, and also then, you know, information about specific ways of doing things. So like there's a lot of courses out there, so I would still want to try to carve some amount of niche of like what kind of lessons haven't been done. But I really don't know what would be the best thing to do. Okay, so this was just telling us like some basic mechanics. There's like a dataset zip function. There's probably a dataset slice function. There might not be. Yeah, I think that would be a good thing to do. TF dataset slice. Okay, so you can just directly do this. Okay, so that's not an issue. If we just directly take in the data instead of args, we can just slice it, and we can say that output is going to be data 0 to 9713, or output 1 is that, and then output 2 is going to be data from 9713 plus 1 on, and then we're going to do return tf.stack output 1, output 2, axis equals 1. So this is just going to give us the input data. So we can just say something like input dataset is equal to format, or dataset dot map format as training. Did they do something special with their stacking? Everything in their stack had the same type. Right. So... format as training takes one positional argument, but 11,272 were given. Alright, I guess we go back to doing args again. But yeah, I think it's the data type issue. Yep. Cannot convert a list containing a tensor of type float 64 to float 32. Okay, so let's check this. Let's check df.dtypes.value counts. And let's hope that there's actually only a couple of weird ones. Okay, so there's 562 float 64s. And there is one int 64. So maybe what we have to do is not convert all of them, but just the ones that are bad to float 32. Like if we go something like for call in df.columns, df call is equal to df call dot as type float 32. How long would this take to run if this were run? Four and a half hours. Let's do for column d type in zip df.columns with df.dtypes. And then we can say if d type is equal to np.float 32, we'll continue and move on. How long does this take? I probably should have given a total. I can stop it real quick. Total is equal to df.shape 1. Okay, it's significantly faster. Right now we just want to get something working, and then we can try to modify back some of the changes that we've made and see if what's the best way of doing it. Yeah, we could probably do it in parallel. Oh, actually, never mind. That was it finished. So just checking if it was already a float 32 and skipping. If it was, made it much faster. So maybe it was just the time it was taking to convert something back into its own format was taking weirdly long or something. Don't know, don't care. Let's see if saving that out to the feather file. helps us in any way. So I'm gonna cut this and paste it in a new one. Oh shoot, our types are gonna be wrong now though. There. Now our output types should be correct. And if we try this format as training, will we get the same issue? Okay, we're getting a different issue. Dimension 0 in both shapes must be equal, but are 9713 and 1158. Oh, well maybe we just don't do axis equals 0, but we do axis, or axis equals 1, but we do axis equals 0? Nope, but now it's giving us the same error. TF concat. Maybe instead of stack, we need to do concat. With axis equals 1. Alright, let's try it again with axis equals 0. I don't think so. I don't think it's axis 0. Okay, well maybe it was. I guess maybe it was axis 0. Okay, that's fine. So now if we... It worked. That's our input data set. And now we need the output data set, which would actually be very easy. Which our output data set is just gonna be, instead of doing all this concatenating and all that, it's just gonna be lambda data. We'll stick using the word data. Data 9713. So now we've got the input data set and the output data set. And the last thing is that we need to zip them together. Oop. In user code. Lambda takes one positional argument, but okay, we just need to structure this function the same way. We're going to rename this as create input, and this one as create output. And this is just gonna simply return data 9713. There. And then our training data set is then going to be tf.data.dataset.zip. And we're going to zip these two together. Because I believe that's something we can do. Yep, that is something we can do. Okay, everything ran. Let's do a for IO in training dataset.take 1. We're going to print i.numpy.shape. We're going to say something like input shape. And then we're going to print output shape. We might not have to do the .numpy. Resources aren't really getting hit that hard. CPU is fine and everything. The hard drive's actually getting hit by a little bit. I wonder if it's this converting it to NumPy that we don't actually need to do. We might have just been able to directly say .shape. But the point is we just want to print what each one's shape is. Yeah, in fact, let's just go ahead and stop it. Uh-oh. It doesn't want to stop. Speaking of waiting for things to run, how close is our million battle simulator to finishing? Pretty close. It's at 564,000 battles in that folder, and then it's like 380 in the other one. So we're almost done. Okay, I'm just going to go ahead and restart the kernel. We've already saved the file. So we can just restart the kernel and run each item. Oh, oops. It's supposed to be create input, not format as training. Type error. Great. Now, why would that be? This was just working a second ago. Oh, the types are wrong because of this thing. So instead, everything is a TensorFlow float 32 now. So the types being wrong might have caused the problem. That was the issue. Okay, now let's try this take thing again. I guess we could also just run element spec. But it'll be very crowded. Okay, there we go. It took a while to run the dot take, but it got there. So we can see that one batch of the results, take one pulls one batch, had 11,271 by 8 as the input, and for output had 8. So just running one take function took a long time. So there's clearly some optimization, maybe moving it off of the slow hard drive and onto a faster hard drive will make our training time better too. Because I think it's probably going to be very slow by the loading of these files. Like these batch sizes might be too large. Not the 8, but the 100,000 rows in one file. It might be better to have a lot of different files. But either way, now we've got the training dataset. And it is as a dataset, and it's in exactly the format we need. So finally this nightmare can end, and we can just create the model and see it training. Finally. Okay, so let's just create a very, very basic model that we know for a fact won't cause us any problems. This model will not be good, but it should be relatively fast, and we should know that any slowdown is not due to the model architecture. So we're just going to create a sequential model. So we're going to say model is equal to tf.keras.models.sequential. And then we're going to add a dense layer. So we're going to say model.add tf.keras.layers.dense. And this is going to be a dense layer with, I don't know, something small. 64 neurons. Then we're going to add a tf.keras.layers.dense with 1. So this is a 2-layer network. It just has 64 neurons. This one, the activation is going to be relu, and this one, the activation we haven't done any sort of normalization on our data. We haven't done any kind of cleaning, so we're just going to not have an activation function. Then we're going to say model.compile, and we need to give things like the loss function and other things in here. So let's go back to that tutorial that we just had. They had some things we could copy paste. So we're going to use for loss just mean squared error. The optimizer is going to be atom, and we're not going to have any metrics because we don't have any metrics. And then we're just going to say model.fit on the training dataset. Epochs equal 1 epoch verbose is equal to 1. Okay, so we should, once the model gets initialized, we should be able to see it start printing the out information about the training. Oh, value error. Oh, we need to define the input shape. Oops. The input shape of this is going to be a 11271 by whatever vector. Right. So this should be a horrible model. This shouldn't be anything good because it's out of 11,000 input columns. It's got 64 neurons to try to deal with that, and it's just one layer with nothing fancy going on under the hood. Also, none of the data has been normalized, which means training will probably just kind of explode in terms of how bad it is. But we should be able to see pretty soon how if it's training and if it's working at all. Yeah, so for normalizing data, while this is running, I'll just open up a whiteboard. Honestly, the 8 epoch thing is probably, or the 8 batch size is probably actually hurting it as well. Okay, but what's going on right now, and to answer kind of both of those questions at the same time, is that what we've done is we've simulated a lot of battles. And we have this big log file that has information row by row of what has happened. Ooh. Uh-oh. Invalid argument, matrix size incompatible. Is it talking about this 64? Like if I change this to 32, is it gonna still have an error? Oh, the camera view is over. I'll move the camera. Or I'll just swap these two windows for now. Okay. So what's going on is we have this big log of a whole lot of information. And then each log represents one turn, basically the observation of a certain player at that turn. And we also know who won every battle. So what we can do is, and what we did do on Thursday, and now it's saved in these like feather files, is we've scored each battle using a kind of scoring function. Like I can show if we open up MBS log parser. Basically what it does is it just looks at what happened every single turn and either adds or subtracts points based off of the result. So if you win, you get a certain amount of points. If you lose a certain amount of points. If you take damage, you increase your points by like basically something proportional to how much damage you did, etc. If you switch, then no points are rewarded, but it just changes some details. Yada yada yada, for like a couple different things. And how we calculate the score doesn't matter as much as creating a model that can predict what that score would be. So basically we have taken this log and we add on a bunch of scores for each row. And the idea is given an observation plus a move. So we say observation, so what's going on in the battle right now. And we add on what choice was made, like a choice that you make. Can we use the two of these to predict what score you'll get at the end of the battle? Basically, if I choose to use this move at this point in time, how good is how well will my performance be overall in the battle? This isn't perfect. Instead, we'd probably want it to be a combination of both the overall game score, so this is the game score, like after everything is said and done, and then also something about like the turn score of just how much is it going to help me right now in the moment. That way we could kind of create some sort of greedy algorithm that just tries to maximize each turn score, and it might be simpler. But for now, it's just trying to predict based off of what I see and what I'm choosing to do right now, how is that going to go for me? So the model is doing exactly this. It takes in this big vector of all of the observations about the game, and it tries, plus the choice, a vector about the choice, and it tries to predict the score. That's what our model is doing. So this score is just some number. It could be negative, it could be positive, and it's just like a integer. By normalizing the score, what we mean is that we might want this to be a number between -1 and +1, based off of where like a 0 is like an average game, 1 is like the best game ever, and a -1 is like the worst game ever. Machine learning models tend to have an easier time when it's something like that. It's relatively limited, instead of it being just kind of any value. Right now it's not normalized, so it could have a value in like the thousands. In fact, we might have a graph from before. Maybe not. No, I don't have the graph from before. I plotted a histogram before of the results, but I don't have that right now. If this will ever get started training, that would be nice. I'm not sure what part of it is taking so long. There should be some sort of tool to see like GPU usage, but I had used it before, but I don't remember what the tool was called. It might be in like the NVIDIA control panel or something. Yeah, like I know like NVIDIA has a console, and so maybe it's not the. Okay, so it's at like 30 to 40% usage. So it's doing something, but that could just be the streaming. All right, I'm gonna just close out of that. But so what this output gives, invalid argument. Yeah, and is it gonna say something about 32? Yeah. Okay, so matrix size incompatible. It doesn't like that this dense layer. All right, we'll add an input layer. That's fine. Whatever. tf.keras.layers dot input. Tensorflow Keras input layer. Maybe adding an input layer will save us. Value error. Okay, well, let that run again. Okay, so what we're gonna do with this score then is that at runtime, the observation will be able to be generated. So we can generate this observation. And then for the same observation, we might have 5 or 6 different choices. We might have 4 moves that we could use. Or actually, there will probably be like, at most, like 11 choices that you could make. You could use one of your moves, or you could switch to one of the 5 other Pokemon. So that would be 9 choices. 9 is a very small number. Unlike with team building, where we had trillions of choices in theory of exact teams with exact move sets and everything else. Once you're actually in battle and you've got a Pokemon out in front of you, the action space is pretty limited. It's like 9 options. So what we'll do is we'll just take each of those 9, or and actually for what we're doing, the Nuzlocke we're playing, you aren't allowed to use items. So like that's typically called like a hardcore Nuzlocke, is where you're not allowed to use items in battle. It makes it easier for us because it means we don't have to train a model to use items. But it's part of the harder rule set that people use. Also in like competitive battles, you're not allowed to use items either. So there'll basically be up to 9 options to take, and we'll predict what would be the score for each of those 9 options and pick the one that has the highest score. And for the reinforcement learning part is that it will try to do exactly that, but it will be live updating its scores based off, or its weights based off of those scores. In this case, the difference between picking an integer 1 to 9 or one hot encoding it is that if your choices are unrelated, you don't want them to be numerically related. And so because of the fact that we'll have a flexible amount of options, we're doing this kind of roundabout way where it predicts the score rather than predicting the choice. We could, instead of doing this game score approach, just do the observation and try to predict the best choice and kind of get rid of all this together. But then the difficulty is that sometimes you have more choices than others, so it becomes a lot harder to have a general model. So instead, we're doing this plus choice to then predict the game score, and just run the predicting algorithm for as many choices as you have, which at most will be 9. And 9 is not a lot. 9 is pretty small. And go from there. I wonder what's taking this model so long to run. It might be something about the file format, like the batch sizes might be too small. One thing that we can do that would make things still pretty easy, or not change anything about it, is let's go ahead and stop this, because I think a lot of the effort is in like loading the data set from the files. I'm just gonna go ahead and restart that. Also, we can get rid of that line. What we're going to do is one of the options for creating this whole so basically this is how some like kind of more deep QN approaches for reinforcement learning work. And the idea is that this is the approach you have to do when you have a flexible action space. Because otherwise, what's to stop the model from predicting an action that is illegal for it to take? So I'm not sure what the exact name in reinforcement learning would be for this, but this is the kind of motivation behind it, and it is something that you do, and you do see in reinforcement learning. It's for games where you have a flexible amount of choices. From pandas. So what we're going to do here is we're going to just say df is equal to pd.read feather, and we're going to have it read the example one. And then I'm going to comment this stuff out right now because I don't think we need it. And then we'll tell it to do from pandas df batch size is equal to about 1024, or just still 64. Let's do batch size still equal to 64. Preserve index equals false. Okay. Let's see if doing the loaded into memory gives us a big performance increase, because that just tells us it's an issue with the way we've got all of our files set up, and that needs to be fixed. Okay, our dataset was created. All of the other code in theory should work, but maybe nope, okay, it worked. And now we're at the last one. This time we've just loaded it into memory. So our memory usage is higher now. We're using about, come on, show me how much more memory we're using. We're using about 10 to 15 gigs more memory than we were using before, because we just loaded the whole thing, that whole file. But let's see if it paid off because of efficiency or something. It still is taking a long time to even start fitting though. Invalid argument error. Matrix size incompatible. Why? Does the model fit need to have like a batch size that's specified? I didn't think it needed to. Okay, so they're doing scaling here, but we don't need to do scaling yet. Let's go to the IO thing again. API. Tensorflow IO. Let's try to find the exact information. Arrow dataset, and then this has a function that is called like from pandas. Okay, so batch size is being set here, but maybe what we should do is change how the batch size is working. So instead of doing batch size equals 64, say batch size equals none, and batch mode is equal to auto. That's one of the things that people keep recommending. I guess that might work. This might lead to a batch size of 100,000. I'm not sure. Like, it might end up using all of the records as the batch size. I'm going to move the task manager over to the active window. It's taking like 10 minutes to move the task manager over. You can see the window just slowly coming over. This is what I mean. Whatever reason, windows just take forever to move around. Especially when anything is happening. I can see that the code finished running, but I can't get access to it because there's the slow-moving task manager window in the way. It's at like a 2-minute delay. It's just moving completely on its own. You can see my old mouse is what's dragging it around. Let me click on this window. I just want to see where it failed, if it failed. Okay, yeah, sure. As soon as I get freedom from this torture of it's still going on. Yeah, like, and so realistically, there's no reason my computer should be doing this, right? Like, you can see, like, this is a Threadripper 24-core computer, and I'm at 30% CPU usage and less than half memory usage. It's still going. This is more like a 5-minute delay in dragging windows around. This is going to take longer than training the model. Getting Windows to stop being itself. What is going on? Oh, I thought we had it. I thought it had stopped. I thought it would finally click into place because it sped up. But no, it's still going. I don't know. Oh, did it stop? It finally stopped. Okay, so you don't get to just... We've seen Task Manager enough, I guess. Resource exhaust. Yeah, okay, so it seems like... It seems like whenever we don't give a batch size, it's allocating everything. We can go ahead and step up how much memory the GPU is using. I'm scared to move Task Manager around, but you can see that on the GPU, we've got tons of available memory. So I'm going to step up the GPU memory to be like 12 gigs, just so that we have it. But I do think that the batch size thing is causing an issue. Let's just go ahead and specify the batch size in it. I feel like this is the wrong thing to do. You don't normally have to specify the batch size. I don't know why it's asking for the batch size. So this is my personal one. This is my personal machine. I have spent way too much money on it over COVID. The most I've put it through is a couple of months ago. I was training a machine translation model to go between Japanese and English. And maybe after this project, I'll open that project up again and work on it. Just because since I've already done a lot of work towards it, it would actually just be something that takes maybe like a week or two, and it'd be a shorter term project. And I can make videos about it and all that. So it wouldn't be something I would be doing live as much as it would be something that I could just already show a lot of and just finish it up. But yeah, as for specs, it's Task Manager is closed, but I can just tell you by heart. It's a Ryzen Threadripper, like 24 core Threadripper. It's like the 3960X. It's got 256 gigs of RAM. It's got an RTX A5000 graphics card, which is a 24 gig VRAM graphics card. It's invalid argument error. Model was constructed with shape none by... Oh, you know what? Oh, I'm just dumb. It's supposed to go none and then the shape. I'm pretty sure it's supposed to go none and then the shape. Not the shape and then none. Maybe. I don't know. But, yeah, it's got RTX 85000, which is a little bit weaker than, like, a 3090. But it's, like, the enterprise-style graphics card, or it's, like, a workstation graphics card instead. Was constructed with shape none 11271. Okay, I don't get it. What does it want from me? But yeah, like the last project that I was working on, it was also just for my own purposes. It was a machine translation model, but more than that, it was also like a framework. So that I can, like, the idea would be for playing games in Japanese, or conversely playing games in English, if you only spoke Japanese or could read Japanese. And it was basically crowdsourcing translation. So that for commercial translation things, once somebody has looked up a specific sentence, if it already exists in the cache, nobody else has to. Alright, it's once again doing that. It's whatever the batch size is. Whatever the batch size is, it fails. I don't know why this has to be like that. But you know what? Let's just make this neuron... That shouldn't be the case. Yeah, like I don't know what it is. I mean, it's definitely a software issue. Okay, so here they're just fitting, and they create the model, they just give it an input shape, and they're great. What are they doing for the batch size, though? Read and process, which is returning a record batch from pandas. But they don't have to specify the batch size, so why is ours failing whenever, because of this like weird issue? The shape makes sense, because it's supposed to be a blank by none shape where none is just auto-filled in with the batch size. Actually, where are they fitting it? Like, what are they passing in? They're passing in data set. And where are they calling model fit? Because maybe they're doing some extra batching. Make local data set. Let's find that. Batch mode equals auto. Let's go back to checking out layers. Input layer, here it is. Oh wait, no, this is input layer. I need input. tf.keras.layers. Wait, why is it called input layer? Isn't it normally just called input? View aliases. No, it's just... Input shape. I don't think this has to do with the lack of typings. I think it has to do with something going on with the building the TensorFlow dataset. Because the unfortunate part about the TensorFlow dataset idea is that it's not running things whenever you write the lines. It's instead doing oh shoot, what was the size? 11271. It's instead like so-called like lazy dataset, which means it will only compute things at the actual runtime, like the fit of the model, and it's because it's building up this like task graph that gets executed in C. but it means that debugging that task graph in Python is very difficult. So I think that's where the problem is coming from. I don't know why I'm running into this, but clearly I just keep running into the same issue of like the matrix size. Like I think the batch is not done correctly or something. Maybe I need to specify batch size here. You know, it could actually be an issue of training element spec. So yeah, I don't get it. No, the formatting looks perfectly fine here. What does their element spec look like in their tutorial? I thought they printed it somewhere. Did they not? That's a little bit annoying. They didn't print what their element spec is. This looks completely normal to me. Like, this is what it's supposed to look like, this element spec. If we look at input dataset.element spec, it's a tensor of 11,271. What if we did next iter training dataset? Okay, so this is pulling a batch. What next is doing is it pulls one batch of information. Whenever they did next, and they were showing the results, they showed that it matched the batch size, yeah. Okay, so their next, it matches exactly what ours does. Yeah. However, is the first one supposed to be the batch, or is the second one supposed to be the batch in terms of this? It's a little bit inconvenient. X0 is 5.24. Oh, dang it, they reran it and the numbers aren't the same. Dang. I was hoping we could figure it out, because like maybe it's like transposed or something, and it's supposed to be 64 by 11271, because that would actually make sense if that's what's happening here. But I can't tell. Let's look up just other examples and see where they're batching it. Come on, really? Is it not going to show me this? Okay. Batching data elements. Simple batching. So this is a... What? This is a 4x3 data set. Yes, the batch is coming first. So our data is transposed compared to what it's supposed to be. Okay. This is because this is supposed to be however many items you have in your batch long with like your vector size as the width. So for some reason this is transposed. Maybe it's because of this axis equals 0 thing. Maybe it's supposed to be axis equals 1. Yeah, it could just be that we've done this thing wrong. We could do .t to transpose it. Tensorflow transpose. Okay, it's just tf.transpose. Because that would turn it from the format that's wrong to the format that's right. And if it's just a one-dimensional thing, then it wouldn't matter. Okay, and now let's check the element spec. Now it's a none by 11271. So now it might work. Let's see. Still taking a little bit. It might still fail. There we go. Now it's working. And with... Yeah, it works now. We need to tell it how many batches there are because it's just reading from a file and it doesn't know how long that file is. So it's going to be running for a while. Also, we only told it to do one epoch. So let's see. Let me use a calculator real quick. Or actually, last time I was just opening up a calculator over and over again. It's using a batch size of 64, which clearly is within our space. Oh, okay. So, never mind. 1563, which makes sense because... Let's open that back up. 1563 times 64 is just less than one batch over 100,000. So that makes sense. We can definitely do better than that in terms of batching. And also the loss is massive, but that's to be expected. We just have a single 64 layer thing, but the model technically works. So let's switch back to instead of, well, no, let's just step up the batch size. While it's simple and it's working, let's figure out what our batch size should be. So let's just go ahead and go 2048 and see if that, like a much larger batch size makes sense. And then we can, I think, get rid of batch size here. Yes, exactly. Like the batching is just for optimizing the train time of the model. You want to have as large batches as your GPU's VRAM can support. Generally. Like, that's basically always true, though. So we're doing 20 batch sizes of 2048. We might have to tell it still how many steps per epoch, because it might not know how many rows there are, because it's kind of streaming the data. So it might not realize how long it's going to be running. But let's see if 2048 as a batch size also runs. And this, I hate to do it, but let's open up Task Manager again, and let's hope it doesn't take years off of our lives to move this. But if we go to performance, okay, yeah, so you can see stepping up our batch size, it didn't crash due to low memory, but the whole thing took 8 seconds instead of before it took 40 seconds. Which, if we kind of do the math, 2048 divided by 64 is equal to 32 times better. So it wasn't quite 32 times better, but it was, 40 divided by 8, 5 times better. So I think 2048 for now. I mean, I guess we can step it up again. We can even do 10,000. Did it know the full file size? I didn't see it while it was running. I don't know if it knew how many rows there were. It only matters for one epoch, but considering we actually have a very large amount of training data, we'll actually likely be doing something called one-shot training. And it's basically the ultimate way to prevent overfitting. It's that the model only has one shot to learn from an example, and then it never sees it again. So you do only one epoch. You don't train for multiple epochs, you just show all of the data to it once, and you never show it again. So that way it can't possibly memorize exactly what it's seen, and instead it will have to generalize from the data. The disadvantage is that then you require a lot more data to train and a lot more varied data to train, because your model's only going to see it once. Yeah, like that's kind of, it's one of the ideas behind, one-shot learning. Okay, so that time at 100,000 for batch size, it actually took longer. It took 17 seconds. So there is a balancing act. In this case, it might be that pulling 100,000 at a time from the buffer, or what was our batch size? 10,000. Pulling 10,000 at a time from the buffer was too much to pull. So, we could step it down to 5,000 and still be playing around with it to see, what's better. But again, it did say unknown. So what we can do is tell it that the steps per epoch is going to be equal to 100,000 divided by, let's say our batch size is 2,500. We could set this as a variable, but if this works, then we've got that working. Steps per epoch, it might want an integer, and if this division, Python does real division instead of integer divisions by default, it might fail. But yeah, so that solved the issue. I guess, pro tip, if you're ever getting matrix division issues, it must just be that you've messed something up with the shape of your input data, potentially like the batches. Yeah, okay, so 2,500 is the fastest we've seen so far. It took 6 seconds for that epoch. And this is reading one file of data. The loss is massive, right? And we can see that if we do something like 100 epochs instead, that we will end up with data that is, like, the loss will decrease still, but it might not actually decrease and overfit. Partially because our model is so small, but also just because we haven't done any sort of normalization that would really help. Oh, we need to use dot repeat. We might not have to use repeat if we are doing one-shot training, because the whole point of one-shot training is you aren't repeating. But for this example, we can use repeat, and what that does is it just loops the data forever. Yeah, so we can see from this log of results, the loss is kind of coming down, but the loss is at like 98,000 something. So it would take a very long time for the loss to get lower, and by that point it might just be kind of memorizing the data anyways, just because of how many columns we have compared to how many rows. There might be kind of a unique fingerprint about the data that isn't very good for us to try to memorize. But either way, in theory, it's working now. And a batch size of 2,500 seems to be the best for us. So what we'll do is we'll get rid of this repeat, because we don't want to repeat anymore. Our data is still, yeah, I mean, it is a good sign, but what we need to do is two things. We need to have validation data, so we can see that it's not just overfitting to the training data, which the validation data could just be one of our files. We don't need it to be a whole lot of files. It could just be one, and that's perfectly fine. And we need to load all of our other data and normalize it so that the loss isn't some massive, massive number. It's something that's a little bit more reasonable and understanding what's going on. Because right now, the loss is the mean squared error. So it's the average between its prediction and the real answer, that average difference squared. So it's kind of hard to interpret at such large valued numbers. So what we can do, and I really don't want to just load all of these into memory because I don't think I can. Let's see if there's a helpful function in tf-data to batch or to normalize our data. We don't need to shuffle our data. Tensorflow dataset normalize. Okay, so it doesn't learn the mean and everything, but we could add one of these normalization layers. And just set the mean and variance to what the real data is. And then we could just load that histogram that I made before. And because the only column that we need to normalize is the output value, really. Like, the level, I guess, too, we need to normalize. Oh, wait, we want to normalize the output. This would normalize the input. Shoot. Dang. What we might have to do is we might have to change our output script, this MBS log parser script, some details about how it works, so that it will save things in the correct file format with also the right data types. So I think that's worth doing. And the sooner we run it, the better. So I'm going to go over to our notebooks, our batch data. I ran it on 153 batches earlier, and this took like 2 hours to get this much. So unfortunately, we're not going to recover all of this stuff. We still have example.feather, by the way, so it's not the end of the world. But we need to normalize the results and store them as the right data format in advance, so that the files are ready to go. Oh, no module name sklearn. Pip install scikit-learn. Any others? Probably Plotly. Let's install those libraries. What we're going to do is we're just going to recreate some of those feather files. It typically takes like a couple of minutes per feather file. And what this script does is it reads the raw logs and it does all this formatting information for us. Last time we had it, it wasn't cleaned up in all these different functions. But now it's a lot more clean. Yeah, you can see we're at 942,000 battles. What's being printed here is it's reading through the results of every single battle to load a dictionary of what has happened. Okay, but before we save it to a feather file, what we need to do is we need to do this, like, for one, we need to change the data types. So we need to say for call in observation df.columns. For call dtype in zip observation df columns. What did I want to say? Oh yeah, observation df.dtypes. If dtype is equal to numpy.float32, continue. Else, I guess we don't need else actually. We can just say observation df call is equal to no, not as a string call. It is equal to observation df column dot as type np dot float 32. Okay, that's one. We also need to say observation df is equal to observation df dot fill na with 0. And then what else do we need to do? We need to normalize two columns, the level and the game score. So we're going to say observation df. We're going to assume each... actually, we probably don't even need to bother with the level. We'll just do it with the game score. We'll assume each batch of 100,000 games has roughly the same distribution of scores. So we don't need to keep a log of what the actual overall mean is and normalize it that way. We can do batch meaning based off of each of these scores. Dot mean. The mean actually is practically 0. Dot st. The standard deviation is pretty large. Okay. So now, the changes that we had to do manually before were setting the types to specific things. We had to set the types. We had to fill in some NAs. And that was it. And then we also wanted to change the data type. And now this will change the data type. So that's good. Then the way that this works is it actually loads in a label encoder list, or a Python object that has a bunch of label encoders. Read bytes. That way every column or every file has the same columns in it. And we're not going to let this run forever. We're just going to let this run to create us a couple of files. What it's doing right now is it's just loading all of the win results to get the scores. And then what we'll do is we'll just run this for a couple of iterations to get a couple of feather files and use those. But it says it's taking like another 9 minutes to load the results of the battles. The load showdown log results could definitely be parallelized. The reason why it's not is just because we were kind of lazy and we just wanted to get it working pretty quickly. But it's basically just going through file by file. It goes through file by file, calculates the game score, which is also just a for loop, which just goes through line by line of the log of the battle and adds points or subtracts points for certain things that happened in the battle. And the way that it works is that it also, if you do something good, you get awarded some points, and the opponent only loses some points if what they did was bad, and they lose less points. But the point is that it's imbalanced, that it's not like every time you gain points, the opponent loses the equal amount of points. Instead, when you do something good, you gain, say, 20 points, and the opponent loses maybe 10. That way, if both random players are just making mistake after mistake after mistake, they can both have pretty low scores. So hopefully battles where there were just still a ton of mistakes don't end up with a mean of 0. They end up with a mean that has a very, very low value. And then random players where both were picking randomly good moves, they'll have a higher mean. And games where just one player played really well, they'll have the highest value for their game score. So it's kind of imbalanced. The only exception is winning or losing, where it is balanced. It's 200 points if you win, and you lose 200 points if you lost. Everything else is kind of imbalanced. Like this, if you use a move that fails, you lose 20 points, but the opponent only gains 10 points. Because maybe it failed because of something they did. Or if they were immune. While that's running, let's go ahead and go over here and start editing the code. That way it's just ready to go as soon as those files are in the folder. So what we're going to do first is we're going to say something like validation df is equal to that. I'm going to cut this and paste it right here. And then we're going to create our validation dataset out of validation df. So the validation df is still going to be made in just memory. Potentially, however, if two players that play perfectly, the number of turns that happen will be lower than just completely random moves that don't do anything. So it has the potential for the points to be not decreased so much. Whereas if two players are just randomly making terrible moves, they can be losing points faster than they gain them back. So it's not a perfect method, and that in reality we do want to include also what happened in that turn as well, so that it knows what to do. But really, like, we're just trying to say what is a good choice for a turn. So these are all random players anyways right now that we're simulating, so they're not intelligently making good moves. They just randomly stumble onto it. We just want to kind of have strength in numbers and see that sometimes the random back and forth ended up in a very good set of moves, and so the model can learn from that. Five more minutes of that loading, but so this is the validation dataset, which this method was doing it all in memory. This arrow dataset from pandas is it's loading it in pandas. Then creating the input. So this observation df, this actually fixes the order. The order only got mixed up whenever I was doing things after the fact. So that's good. I can clean this up so that it's not like just a random column that's in the middle. It only got messed up whenever I went back and fixed some things and I sorted the columns. Then that put the good column somewhere in the middle. So I'll be able to change this, where basically we're just going to say output. It actually means we can even simplify this. Output is equal to the last column, and maybe just return output. And then this is just going to return data at -1. So then we'll just say input val dataset and output val dataset. And then lastly, this is going to just say validation dataset, because we're overwriting validation dataset. Okay, so that creates all of this. But I still need to then create the one that's based off of files, where it's going to use all of these feather files. Which is done by doing this. We're going to say create training dataset, which is going to have, instead of arrow dataset from pandas, we need to, I had another tab somewhere, I've created too many tabs. arrow feather dataset. Which, instead of using the df, oh, changed the wrong place. Need to change it here. It's going to use feather files, a list of feather files. The batch size is going to be the same. Batch mode by default is keep remainder, so we don't actually need that. But what we do need is the list of file names, the feather columns, and then the output types, which has to be a tuple for some reason. And then preserve index is not a feature that this uses. And then this is called test dataset, or not test dataset, train dataset, which then we are going to do here. All right, and then lastly, we have the train dataset, which is our input, and then Keras fit validation. It's validation underscore data. Validation underscore data is equal to validation dataset. So this will actually give us information about the loss of the validation data instead of just information about the loss of our training data. So we can see if it's overfitting or not. We'll still keep the same steps per epoch, but instead of epochs being 100, epochs is going to be however many feather files we have. Okay, this finished. So now let's go ahead and create let's create 5 feather files. This will take a couple of minutes to run. But this is doing everything that we were working on last Tuesday, which was basically reading this raw log file, which I am kind of curious how large the log file is now. The log file millionbattle.log is 144 gigs. So this is just a raw text file that has the turn observation data of every single battle, or every single turn for every battle that's being simulated. So this is a very, very large file. And this doesn't have the results of the battles. This is just the raw observations of what's going on. We're doing it from 2 different perspectives because we log both players, what they see. That way we get kind of twice the training data for little effort. But yeah, so once this creates a couple feather files, then we'll start the training just to make sure that it works. And then we can wait for a little bit for it to create them. Yeah, like feather, it's much quicker than like CSV files. I was originally just saving them as CSV, but each CSV was ending up being like 4 gigs, whereas the feather files were end up like 62 meg. So it's way, way, way more efficient in terms of storage space. And it's also just much, much faster for it to load into pandas and to save to pandas. So I think it's just a more efficient thing than the other methods. Yep, okay, and there's, you can see batch 0.feather. So it's created the first feather file. Or it's writing the first one. So long term, I don't know how many files there's going to be. But just to get this working, I'm just going to let it run for a few minutes to create 3 or 4 files. And then we'll go from there. Like earlier, it took a couple of hours to generate like 150 feather files. But since I didn't test any of this stuff in advance, I didn't realize that I'd need to be recreating them to fix some pretty critical errors. So we'll still have a model, but it will probably just not be very good. But I don't know, like this is still not a trivial amount of data. Each file contains 100,000 turns of observations. So it's still not bad. But I want to get enough so that, I guess what we'll do is we'll say batch data slash batch 0 is our validation data. And then this is going to be sorted all of these from 1 on. So it's going to be like batch 0 is our validation set. And then all of the other feather files, however many there are, is going to be our number of training data. So our epochs is actually just going to be the length of feather files. We're going to set a batch size up here to be 2500. So we'll replace all of the 2500s with that batch size parameter. Steps per epoch, that we can hard code that as 100,000 because that's just whatever. Input shape is going to be yeah, so the model is just going to be predicting at a turn level anyways, so it's okay if one battle is split across multiple feather files. And actually, the way that these like file loading data sets work is that they can actually read from multiple files at the same time to improve your parallelism. So it's okay. Okay, we have at least one file for training. I'm gonna wait for like maybe one more and then I'll run it. The input shape should still be the same because we're using the same data with the same label encoders. But I guess we can go ahead and let's go ahead and restart and run all cells because we'll have at least one file for training, so that's fine. And this over here is just giving us more data as we're debugging this code. So it's loading the validation set. Exactly. Each turn is treated as a completely independent thing. Oh, df is not defined because we called it validation df now. Is there another feather file? Is it? Okay, it just gave us another feather file. So we'll be training on 2 feather files. There's our training data set created. Let's see, these 2 load. I guess I should add some print statements here. Constructing validation data set. Print constructing training data set. Okay, it finished running. It didn't have any errors. And let's see this. It'll start printing progress as soon as it's ready, I guess. We might have to move the feather files to a faster hard drive. Oh, value error. Okay, let's see what's going on. Sequential expects 1 input, but it received 11,271. Okay, the shape of the data is not right. Maybe we need to do this tf.stack. Axis equals 1. Let's print out what input val dataset dot element spec is. Yeah, it's separating everything out into individual things. Wait, what? One of these is float 64. That's not right. They're supposed to all be float 32. What the heck? Validation df dot dtypes dot value counts. Some of these are different floats again. Let's copy this again. So right now, it's simply trying to guess, based off of the move that it's choosing, how well is the whole game gonna go with everything else. So that might be too abstract because one move doesn't make a whole battle. But the way of doing what you're saying, of like trying to make choices based off of long-term predictions versus short-term, is that this one would be for long-term predictions, like what's the outcome of the battle if we choose this, versus short-term, which is how many points will I get for this turn if I use this move. For now, the game-wide one is kind of easier to do and can still be a completely reasonable thing to do. So we're trying it. Otherwise we'll you know what? I bet that I didn't want that to happen. Let's see. Print changing data types. I think I forgot to rerun this function whenever I made the change. Right as soon as it finished too, right? It just finished all of these. Oh.
Cookies and cream.
Thank you. I have like 3 drinks up here now that I need to drink very quickly before they all go lukewarm.
Do you want me to take anything back up to the downstairs?
No, I'm okay.
Are you sure?
Yeah.
Do you want me to
I mean, sure, I guess. Thanks. No, I'm good. Okay, so it's recreating the files again. I think I just forgot to save the changes before I ran it, so it didn't do the reformatting, which is annoying. Okay. Yeah, it's like a Oreo milkshake drink thing. I don't remember what she said exactly. I heard the blender going on downstairs, so I think she made some drinks. It's like, we don't have Oreos, so I don't know how she made this, but they don't really have Oreos in Japan, which is kind of annoying, because I like Oreos. They also don't really have chocolate milk in Japan, which I love chocolate milk. I haven't had good chocolate milk in such a long time. But I think that's just because I'm an American, so I like things that are incredibly unhealthy for you, like chocolate milk. Changing data types. Okay, now it's actually changing data types. And we'll be able to load batch0.feather and see if it actually worked. Once it creates this file again, then it moves on to the next one. Now this function takes much longer. I wonder if, like, I won't do it right now. Maybe tomorrow I'll do it just as an optimization so that this can just run faster. I'm not really sure why we're getting a bunch of different data types anyways. Like the integer I can understand because I'm casting it to an integer. So it, like whenever I was creating the scores, it is an integer. And I could just fix that by not doing it to an integer. And that's easy. But I'm not really sure why some of the things are like float 32 and some of them are float 34. Float 32 only shows up in the code twice, and it's right here. What about float 64? Doesn't show up anywhere. So I don't know where it's getting the float 64 columns. I guess I could check what those columns are. To me, it just kind of seems like some random ones. 502 random ones. I've had deep fried butter, I'll have you know, and it is exactly what you expect deep fried butter to be. Okay, so all the statuses. All the statuses seem to have this problem, as are the boosts and attack things. It seems like it's our categorical columns except for status that is the different data type. Yeah, it really is a thing. Also I've had deep fried Oreos. That's a thing. Deep fried ice cream. What else weird have I had that's deep fried? I'm not sure what else weird I've had deep fried. But those are the main weird ones. Like it's not a normal food by any means. Like it's not like you would even get it at like a store or anywhere like that. You really wouldn't. It's it's much more of a novelty thing, like at like a state fair, you might get. I've never had a deep fried insect, but I have had a scorpion lollipop. It was like a lollipop where the center was a scorpion. It was like a real scorpion. It wasn't deep fried, but I guess it was coated in sugar, so I guess that is still unhealthy. Okay, so yeah, I just forgot to make the change in our code over here. So now it's redoing things. Starting batch 2 out of 4, so I'm going to go ahead and delete file 2 through 4. Just so we can rerun our stuff and it's not going to use those files. Okay, so these 2 files should be fixed now. It's still working on files 2 through 4, but yeah. But the scorpion thing I had because I used to live in Texas. And the Mexican border is nearby, and scorpion is kind of like one of those kind of weird delicacies in Mexico. So especially at like an airport, there'll be stores that are selling like souvenir scorpion lollipops. Honestly, the biggest leap for me moving to Tokyo is just the fact that nothing here is spicy. There is no spicy food in Tokyo. Which sucks, because I love spicy food. So I just have to do without. In fact, whenever I went back to the US just to visit family for a little bit, I tried to eat some spicy food and I couldn't keep up with the rest of my family. My tastes had reset. Like, have either of you seen the show on YouTube, Hot Ones? It's a great series on YouTube. Okay, but nothing spicy by my standards. Like, if you want spicy food, you have to go to a store that lets you, like, choose how spicy it is, and then you have to ask for, like, extra spicy stuff beyond what they allow. Like, at, like, a ramen place, Ichiran, they let you pick on a scale of, you know, whatever, how spicy you want it. And you have to go up to, like, 10x, 12x what the normal is to get it to be spicy. Also, like, you know, there are spicy foods in that way. Like, there's, like, spicy, like, instant ramen. And there's spicy, you know, like, powders. And, like, chili sauces or whatever. But, the main thing that's annoying for me is that there's no, like, spicy peppers that I can buy. Like, I'm used to being able to just buy a bunch of jalapenos. Maybe because I, you know, used to live in Texas. But, there's no, like, spicy, like, peppers that I can use. And that's really annoying to me because I would like to be able to just, you know, use a jalapeno in my food. But no. Okay, it constructed both of those. And now if we check the element spec, the element spec is back to normal. Oh, actually no, it's not back to normal. The element spec is transposed compared to normal. We need to fix that just like we did before. I'm going to add some more print statements here just so we can see. Oh, 1 million battles simulated. It just finished. So we've simulated 1 million battles. Maybe that's part of why my computer has been a little bit unresponsive for some things. So hopefully that'll help, because it did just finish up 1 million battles. Okay, is it in the middle of saving a file right now? Because if it's in the middle of saving a file, I don't want to reload it. So I stopped it and restarted it yesterday morning because I realized that we should get the turn number in the log in case we wanted to do anything like we've been talking about, like having the score for that turn. And if we don't have the score, or if we don't have the turn number, then there's no way of getting that back. So I added the turn number as well as just like a couple more columns, like is it the user's first turn out, just so that we'd have that for the future and we wouldn't have to restart it again. Like, you know, we calculated it out to take like 24 hours, and I restarted it yesterday just a little bit before lunch, so it ended up taking like more like a day and a half instead of like a little under a day and a half instead of 24 hours. But that's pretty within margin. Like if we calculate it out to take a day and it takes about a day and a half, that's okay in my book. All right, let's try training this model on this new set of data sets. So it's just going to be using one file to train, I'm pretty sure. Maybe two files to train. And one file as validation. But let's see how long it takes to train using this flowing from the feather dataset. It will take longer because it's not all in memory. Yeah, it feels like it's taking significantly longer. What's being hit, if anything? I guess my hard drive is being hit a little bit. We might have to change our batch size for the, or not our batch size, but our feather file size. That may be making each file smaller, like only one batch worth, basically what can fit in memory, and just letting it load a whole file at once will be faster. Because as is, like, it's loading into some stuff into a buffer, and then it stops, and then it has to load more stuff into a buffer. Like, our GPU is significantly faster than our hard drive is at serving the data. So, yeah, like that's why it stopped in the middle and then like went on again. So the writing to disk is just other stuff that's going on. I'm also recording this to that hard drive. Like the whole stream is being recorded to my hard drive. So that's what is going on with this constant writing on it. I could move the feather files to a better hard drive. Like maybe like my NVMe drive. And then it would definitely improve the performance, but I think it's some sort of bottleneck between the number of like rows in each file and what it's doing. Because as soon as it loads the data into memory, it flies by. Like the training progress is like instant. And I certainly do have the computer memory for more data to be stored in memory. But this is where Tensorflow Datasets lets you do a lot. Like Tensorflow Datasets is very powerful, but it's also just a little bit janky and a little bit confusing to use. So like what you can do with Tensorflow Datasets is you can construct a pipeline where you go from, for instance, you could go from like CSV files into like you could read a bunch of CSV files into a big buffer, of memory, and then you could read smaller batches from this buffer into your GPU for training. That way, this stuff in the background could be running every single time your buffer is getting cleared, to isolate the impact of reading a CSV from being able to feed stuff to your GPU. So you can construct these really elaborate pipelines. And in fact, we've actually kind of constructed a pipeline of our own in this, that it's not a very advanced pipeline, but in our case what we're doing is we're going from these feather files it's reading a bunch of feather files into this feather file dataset, but it's not reading a whole file at a time. It's reading 2,500 rows at a time, so it's not reading the whole thing. We might want to play around with that and make it do a bigger batch size. And then that batch size is then being fed into our two functions that we just wrote. So then it's being fed into two things. So it's being split into the create input and the output, which then are being zipped together, which then is being passed to the GPU. So you could have a whole lot more steps that are doing different things in your data set, and we could try to optimize this part because I think this part is the very slow part. But here you can see it got through everything. It did everything only once. Our validation loss was 1.2. Because we have the GPU memory, we could try to here do something like arrow feather dataset is equal to batch size times. So the dataset is on that X drive, by the way. Like it's on that hard drive. That's a slow, just spinning disk. Because it's where these feather files are, and these feather files are on that drive. So we could try to experiment with the training data set being given a higher batch size. Like this could just be given something like even 4 times as large. And then from the fitting, say something like batch size is equal to 2,500. And we could see if this makes it any better. So right now the time to beat is that it took about a minute for the second epoch, and it took over 3 minutes for the first epoch. So let's restart and run all cells, especially now that we have all 5 of these files. And let's see what the performance is like now that we've kind of stepped up the training batch size, which is from these files. Okay, constructed the whole datasets, and now it's going to start the training process. And let's see if it ends up going faster than before. The whole process to do 2 epochs took almost 5 minutes. And it's certainly not the GPU's fault. It's the loading the data that's causing the problem. So it could be that just loading more data at once solves it. But since it's still just sitting here for a little bit, clearly there's still some problem. How's our memory looking? Our memory increased by a little bit, but we're not hitting our memory nearly as much as we could be. Oh, and this is definitely one of those you paid for the whole memory, you should use the whole memory situations. Because if you're not using memory, then it's just not doing anything. There's no benefit to it not using that memory. Oh, giving it a specific batch size definitely tanked the performance. Yeah, it definitely crushed the performance. It might have been specifying this batch size though, because then it's batching twice, and that might be the wrong thing to do. Let's just step up the batch size in general. Instead of doing batch size times 4, let's just go ahead and say batch size equals 10,000. That was slower for the validation set, but it might pay off for the training set. And we could make the two batches different. Batch size is different. But, so the feather files, they're always going to be basically constant size because we're just creating a lot of them. But the question is, should we create more smaller ones or fewer large ones? What's going to make it better for us? Now we're going to go from 5 to, I don't know, 500. Let's just leave this running in the background. This will just be giving us more feather files over time. There is a tool that we can use to actually profile this and figure out exactly where the problem is coming from. I haven't actually been able to get it working on this computer though, so I don't know that it will be practical to use. Yeah, I think increasing the batch size didn't work if I'm going to be premature about it. We'll still see how long it's going to take. Yeah, so far that smaller batch size made more sense. So we could also follow what happened in the example that we were reading earlier, because what they were doing in the example earlier, we just didn't copy it because we weren't thinking we were going to need all of that. Where'd it go? Oh, I might have closed out of the example. I know how to get back to it though. But what they were doing is they were going from CSV files to Arrow. And then from Arrow to like the data set. And kind of doing it that way. Yeah, so they were like reading and processing a file, which read a CSV into some blocks. And then they were creating a record batch from that. And then here, they created the read and process file name, which goes through this whole list to create a data set for one CSV file, and then returns the data set. And then here, read and process directory just does this repeatedly for each batch in it. Okay.